All right, we are going. It seems like we've got some people out. A few people. Okay, guys. We are going to continue reviewing this last unit, differential equation. And before we really get going, I will collect the take-home quiz in a minute. But I thought maybe we could just start. Well, actually, let me collect the way you think about that. I want to see if you could translate this into a differential equation. Okay, so we have a little sentence here that I'd like to translate. It says the rate at which the population P changes is directly proportional to the population minus 100. Let's see if we can rewrite that. Anyone want to give it a shot? Cameron. That's correct. So dp dt, that's the rate at which the population P changes, is equals directly. Oh wait, what did you say before the population minus 100? Yeah, there we go. I just want to make sure. I don't know if I heard what I wanted to hear. So K times P minus 100. Really important that you can do that. So take a second. Make sure I tried to color code it so you can see how everything is translated. Because, if you're given a word problem, they ask you to solve it, you can't start separating, integrating, or doing anything until you've translated it. So are there any questions for that? Okay, now I have a little question for you before I go on. A little while ago, we talked about a special differential equation. We said, suppose you have a situation where the rate at which y changes, dy dt, is proportional to y, so that the slope of this graph is always some number times the y coordinate of the point. We separated and integrated this one, and we got a solution that we can always use when we have this differential equation. I was wondering if anyone remembers what that solution is. Law of exponential change. Say it again. So right, what? E to the kt. So whenever we have this differential equation, we've done the work. We've separated, we've integrated, we figured out that c was just y0. We can use this, the law of exponential change. And it doesn't matter if it's a y or a p or whatever. We can use it if we have that. But the do now question I have, this was our differential equation. Could I use this solution for that differential equation? Nope. What's messing it up? That minus 100. Because it's not directly proportional to the amount present to the population. It's proportional to the population minus 100. So I can't just use this ready-made solution. So what would I have to do to solve that differential equation? How do you get what y equals, or p equals, I'm sorry. What are the steps? Separate, nice, and integrate, and then if they give you a point, solve for c. Okay? But it's just this special differential equation that we don't have to do any of that. We just use the solution. Some people like to use this for everything. You can't. Okay, now, you guys, well, before actually I go over a few of the review that you tried, some people tried, I just want to kind of summarize this unit. So that's what I have on your paper. So don't even look at that. Look at that. Oh, went too far. Okay, so in the differential equations unit, this should be on today's notes, right? Somewhere? Yeah. Okay, first topic we covered slope fields, right? A slope field, you got to know how to draw one, and I think you guys are pretty good with that. Just, you use the coordinates of the points to find the slope at that point, and you draw a little line segment of the point. You also want to be able to match a differential equation to a slope field and match a solution to a slope field. And draw the solution in if you're given a slope field. With growth and decay problems, we just talked about this, there's this special differential equation. If you have it, you are allowed to use this solution, y equals y is 0 e to the kt. Yes. Oh yeah, you can separate and integrate and just realize that at t equals 0, y equals y sub 0. So if you plug in 0 for t and y sub 0 for y, you'll get this. Yeah, in fact, that's how we got it. And if you are using that, if you want to speed things up, and again, this is not something you have to memorize, it just makes things easier. If you have this situation, this differential equation, that's the solution. The time it takes for a quantity that's increasing to double is the ln of 2 over k. Yeah. Yeah, if you're given some other differential equation, you can't use that, you can't use this, you can't use any of this stuff. Well, you'll have to separate, integrate, and solve for y, to get it. But with this one differential equation, with the law of exponential change, you don't have to memorize that a time that it takes for the quantity to double is always the ln of 2 over k. You could just put in 2 for y and 1 for y0 and solve for k, or solve for t. Right? I was going to say that's the doubling time. And if k is negative and your quantity is decreasing, the half-life is negative ln of 2 over k. But again, you don't have to memorize it because you could just put in, to find the half-life, you could put in 1 for y and 2 for y0 and solve for t. It's the time that it takes for the quantity to halve. You could put anything you want in for y0 and put half of that in for y. But these little formulas are handy. Sometimes they speed things up. And related to this, the law of exponential change, Newton noticed, I gotta do this right, that the rate at which the temperature changes, capital TDT, is proportional to the difference between the temperature of an object and the room temperature. And from that, we get Newton's law of cooling. And that's what you used on today's quiz that you handed in. So it's not hard to memorize Newton's law of cooling if you know this. Right? Yes. Not sure. I'm trying to cut it back, but I do have it on the review, and I'm still tossing it around. Nope. It's the same thing. I mean, right? Instead of a y, you have a t minus r. Yeah. Yeah. Well, I'll tell you if 30 dead bodies, but it could be something else. The other thing we talked about in the scene, so we talked about slope fields so we could visualize the solution to a differential equation. We talked about a special differential equation and its solution, as well as the related Newton's law of cooling. The other thing, which we spent a little time on, not too much, when you're given a differential equation and you want to solve it and it's not that one, you have to separate, integrate, to get the general solution. That would still have a c in it. But if you're given a particular point, you can solve for c. You separate, integrate, and solve for c. Right, let's go to that. And I think that. Oh, and then yesterday we said, we could put some old things, some old topics into questions with these. Like, so suppose you're given the derivative, you're given a differential equation, you should be able to write the equation of the tangent line at a given point. We did that yesterday with the texting monkeys. Remember that? And then you can use your tangent line equation to approximate the value of the function at some value c. You just plug c into the x of your tangent line. We did that yesterday. The other thing that you can be asked to do with a differential equation is find the second derivative. You got to find the derivative of the first derivative. There's one of those, I think, in the review question 6. Actually, several. And then, if you know the value of the second derivative, where you drew the tangent line, that can help you determine if your linear approximation is under or over, because you'll know the concavity. So that's like everything rushed in a nutshell, but I just wanted to have an overview of what this topic covers. Now we'll go back. I don't even look at anything. Okay. Questions 1 and 2 in the review. Did you do it? Kids that were here? I know some kids weren't here and I didn't give it to you. Anyone do questions 1 and 2? Okay, you got 1 and 2, because I don't want to tell you. What did you get for 1 and 2 in that order? D and D, D and A. Okay. You got DNA also. What if it's neat? No, it is one of those. Okay, so 1 is D and 2 is A, but I wanted people to say something else than just the right answer because, well, thank you. I needed that because I want to go over why it's not what you thought it was. Because I'll just get myself a little copy here. So for number 1, these are the hardest questions. When you have to match the slope field to the differential equation, it's not what it looks like. You just have to make sure that all the slopes are right. So in 1, you want to look for where the slope is 0. It should be 0 when the x and y coordinates are the same. You already found your mistake? Well, the thing, you had said D originally though, right? Oh, because it's very hard to say. Okay. All right, that was a good reason. Let me tell you another thing about that D that might raise a little red flag. Whenever your derivative is a product or a quotient, the sign of the slope should be the same within any quadrant. Like it shouldn't change inside of a quadrant from positive to negative or vice versa. Well, in D, oh, you're right, it doesn't. But, okay, that is a good reason. So far you'd be good with D. But then you can figure out whether the slope should be positive or negative in each quadrant. It's like in the first quadrant, both the x and y coordinates are positive. So the slope, which is y over x, should be what? If it's a positive over a positive, they should be positive there. Now, and then like in the second quadrant, where the y's are positives but the x are negatives, you expect the slopes to be negative, and they are. D would have been right if the differential equation had been negative y over x. So it's just the sign that was off. Are there any other questions on 1 and 2 that you're puzzled about? Matching those? Did you guys try 3 or 4 or no? You did? Okay. Tell me what you got for 3. 3 got C. Some people got D, which is understandable. Yeah, you can. Okay, and what about 4? B. Now, it is, I would totally understand that if you didn't get C, if you got D for 3. The only thing that would be slightly off for it to be y equals x squared is at 0, it really should be like more horizontal. If it was y equals x squared, it just should, the slope here at 0 should be 0. I mean, it's very subtle. Yeah, the difference. I could say definitely if you pick D instead of C. Oh, I think right with these arms. Yeah, so this is C. And this is B. Okay. Did you get any further? Or are we done with what you did? Try to do 5? Okay, 6 is definitely a tricky one because of the value of C. It's tough. Let's talk about 5. In 5, they give you the slope field and they want you to sketch the solution through particular points. It is a weird slope field. Mine, I tried to duplicate on my calculator. When you look at it, it looks like you have like a slant asymptote. And yours is a little more clear. I tried to highlight that in green. Like you have all these little lines like going like that. But what you do is you just go to the given point. So you start at negative 1, 1, negative 1, 1. You go to that point. And through that point, you just try to follow the slopes. And if you ever get stuck, just think of the coordinates of where you are and figure out what the slope should be there. Oh, that's cute. So that'll help you determine whether your slope should be negative or positive. Actually, mine should have been more 0 here at, at 0, 0. If I came through this point, depends how low you go. But the slope should always equal the x coordinate of where you are minus the y coordinate of where you are. Well, no, if you had gone like a little lower like this, then it would be more over here where we bottom out. That doesn't really matter to me. You're just trying to follow it and try to get the general shape, and I kind of saw that asymptote. But really, if you get stuck with that, this one was hard. The one in your test isn't going to be as hard as that. Just think of the coordinates of the point wherever you are and use them, plug them into the differential equation to figure out what the slope should be there. So once you get to the points where, you know, the x coordinates are greater than the y's, should have a positive slope. And then the other point was 0, -2. So you go to the point 0, -2 and go with the flow. So you make sure it goes to that point and just kind of follow through. All right, so 6 you haven't had a chance to try, right? Oh, well, B, I have to say, that is a tough C. If you try to plug it into your calculator, you're going to get all confused. It's better to leave C in terms of E. Do you want to do this one together, or would you rather give you time? All right, like what, give you 10 minutes? Okay, go. Yeah, come on. All right, I'm going to go through 6. I'm not going to, well, how are we with the slope field for 6? Are we all right with that? Yeah. Okay, for number 6, did I press? Yeah. With the slope field, the nice thing, when you have x to an even power, it's not going to matter whether you plug in -1 for x or +1 for x. Right? If x is an even power, so you kind of get like 2 points for the price of 1. So if you use the, first of all, I figure out where it's 0. What is a fraction 0? When the numerator is 0, the denominator is not 0. So this slope will be 0 when y is 1, but x is not 0. So when y is 1, these points. Okay, notice they gave you 9 points. They like darkened them in, and you got to make sure that you have a slope at each of these 9 points. They won't ask you to draw a little slope field line when the denominator is 0. Okay, they don't want you to, so they'll never ask you to do that. There are none there. Next to 0. So first you want to make sure that where your slope is 0, you got those right. And then you go to some other points. Like if you go to the point 1, 0, 0 minus 1 is -1 over 1 squared. -1 over 1 is -1. So your slope here is -1. Well, it should be the exact same at the point -1, 0. Correct? Over -1 squared. That's why, so it's going to be the same here as here. So it's nice because when you have an even exponent on your x, it's not going to matter whether you're at 1, x is 1 or -1, you should have the same slope here and here. And then when you use the point 1, 2, you're going to get a slope of +1, because 2 minus 1 is 1 over 1 squared. Same thing over here when x is -1. So your slopes here and here should also be 1. So 1, 1, and these are -1, -1. At the other points, you just do them separately. At the point 2, 0, 0 minus 1, -1 over 2 squared, -1/4 here. Try to make it look like the slope is, it's not as steep as your slope for -1. Make it look like, you know, a little flatter. And over here at 2, 2, the slope is going to be 2 minus 1, so 1 over 2 squared, or 1/4. 9, make sure if it says draw a slope field at the 9 points indicated, make sure you drew 9 of the little guys. Okay, so with B, the first thing you had to do to solve this was separate the variables. And this was dy dx equals y minus 1 over x squared. And I guess this caused a little bit of problems separating. All right, well, you know you want the y's on the left because the dy is in the numerator. Right? And that's always going to happen. differentials have to be in the numerator. So to get that y minus 1 to the left, what would you do? Oh, you want to cross multiply first? Fine. Okay. So x squared dy equals y minus 1 dx. And we'll divide each side by y minus 1. And then divide each side by x squared. It seems like a lot of work. Right? Like I know, you don't want to be wrong, so I don't want to discourage you from taking all these steps. Fine. So divide each side by y minus 1. Right? And then divide each side by x squared. So the separating... I'm exhausted. That's a lot. Alright, so no, I don't want you guys just flipping things around in your head, I guess. Alright, so anyway, it's separated. There we go. Okay, now we go to integrate. A lot of people had x squared dx over here, so they just were wrong after this point. But if you had it separated right, what is the antiderivative of the left side? Gina? Y minus 1? Yeah. Okay. Sorry, didn't hear it. All right, now for the other side, it's not an ln. Not everything's an ln, kids. If it was dx over x, sure, it'd be an ln, but it's dx over x squared, and that is not the derivative of the denominator. Yeah, because this side, you have to rewrite it as the antiderivative of x to negative 2 dx and use the good old power rule. You add the 1 to the exponent. No. No. And then multiply by the reciprocal. So then we have on this side, no, you can write it as negative x to negative 1 or negative 1 over x. What do you guys want? And then we have to remember the plus c. We separated, we integrated, we got ourselves some points, but we are not finished. Yes, well, exponentiate. So e to this side equals e to this side. Please don't say that this is e to the negative 1 over x and then plus c, right? It's not going to be plus c. No, that would be wrong to say plus c. All right. So we have y minus... Why did I switch color? Back. It's confusing. So we have the y minus 1. If we broke it up to e to the negative 1 over x times e to the c, we could do that, but then call that second factor our new c. So when I write this side, what should it look like? Just c times c. If you write the plus c at the end, c over. Oh, that's lovely. Yeah, c over e to the 1. All right. So, people wanted to add the 1. That's fine. So I add the 1 in the front or in the back? Back? All right. C, e, the negative 1 over x plus 1. Okay. Now we can't avoid it any longer. We got to find c. So the point that they gave us, and I know you want to plug the 0 in, well, actually, you'd have trouble if you did that. You catch yourself. The point is 2, 0. So this time, so easy. Yeah, what am I plugging in for y? 0 equals CE. It's going to be negative 1/2 plus 1. And I know at this point, everyone's panicking and grabbing their calculators. It's a fraction. But no, you can do it. Because these questions you'll never be allowed to have your calculator with. Yeah. Well, we have to solve for c. If this was just an x instead of a c, what's the first thing you would do to solve for c? No. negative 1 equals c times e to the negative 1/2. Then what would you do? Divide by e to the negative 1/2. I'm going as fast as I can. Nope. Okay. So instead of dividing by e to the negative 1/2, we can bring it up, and it'll just be negative 1 times e to the positive 1/2. So negative rad e is our c. I know. Doesn't that sound good? Kid walking by. What? C is equal to negative rad e. Yep. Now, if we go and we put that back, our solution is y equals negative e to the 1/2 times e to the negative, 1 over x. Yeah, negative 1 over x. Plus 1. I'm sorry, I can't reach. And it's hard. When you multiply with the same base, don't stress me out, you keep the base, it's going to be negative, but you add the exponents. Like a little robot. Keep the base, add the exponents. Yeah, when you multiply, right, and you just keep the base, add the exponents. So it's 1/2 minus 1 over x. Plus 1. So that's a good solution, right? All right, kids, have fun with the rest of it tonight. So when you want to find the limit of this, to get the limit as x approaches infinity, just think about what would happen if x went to infinity. If this went to infinity, what is the fraction 1 over x going to approach? What is 1 over a number that's getting larger and larger and larger? Yeah, it's getting smaller. It's going to 0. So this is going to 0. So what you're going to get is just negative e to the 1/2. I don't have to write minus 0, plus 1. That's the limit. Yeah, this plus 1 is regular. It was here. So this is 0. Yeah, so this just goes to 0, and it doesn't affect anything else. And that's it. The next part, use the quotient rule. Take the derivative of the first derivative. You got it? All right. I'm not going to